Hello friends and welcome back. So, previous lecture we were discussing some water quality parameters and we concluded the discussion on dissolved oxygen. Okay. We will continue the discussions on a few more water quality parameters in this lecture. The one that we are going to start with is one of the very common or very frequently coined term BOD. BOD is essentially the biochemical oxygen demand. Some people refer it as a biological oxygen demand, both are correct. Okay, there is no preferential that whether it should be called biochemical oxygen demand or biological oxygen demand. It is actually both are correct because predominantly the demand is exerted by the microorganism. So, it is biological oxygen demand, but it is from the biochemical reaction, that is why it is referred as biochemical oxygen demand as well. So, you see what happens when the organic matter or pollutant which are present in the water or which comes in the water through the waste disposal. So, this organic matter when it is present in the water and there are microorganisms also present in the water. So, microorganisms will have obviously their natural growth in any system, okay, provided the availability of food and nutrients are ensured. So, the microorganisms tend to grow. They in order to grow, in order to basically survive, in order to manage their food, how microorganisms survive? What is the food for microorganisms? Food for microorganisms are the organic matter. Now, when our waste has a lot of organic matter which are present in the water, so and we are adding that waste to the water, we are or directly even if let us say wastewater. So, in the wastewater there is ample amount of organic matter present, and when the bacteria gets in contact to that organic matter, they tend to utilize that organic matter as a substrate or as a food source. Okay. Many times they can actually utilize these substances for other requirements also, like for nutrient source, for nitrogen or phosphorus source or for other elemental source. So, they can utilize these some of these pollutants because the organic matter present in the water is a pollutant, okay, and for bacteria it is a food material there. So, bacteria utilize that as a substrate, okay, or microorganisms utilize that as a substrate. Now, often many of such compounds when they utilize, what they do, how means because see our it may contain high end sugar, proteins, fatty acids, lipids, okay. But when the bacteria attacks these substances, they break down these substances to smaller compounds, okay, and this breaking down could go as low as to the breaking in the carbon dioxide or water, okay. So, the complete breakage is called mineralization. So, bacteria tend to mineralize. This mineralization always essentially may not be complete. So, it is not necessary that if there is a lipid, so bacteria is going to break it down to a level of CO2 and H2O, but they can at least or many times they can break it down to significant levels, significant smaller compounds or simpler compounds, and then another group of bacteria can so on work on that. It can actually completely mineralize it also, but that will require much larger time, okay. So, what happens that bacteria attacks these substrate, bacteria attacks this organic matter, utilize them as a substrate, and in order to that the compounds are degraded and the bacteria grows, okay, because they get food, they get nutrients, so they multiply, they synthesize new cells, and for synthesis of new cells also, cells are made of what? Carbon, nitrogen, okay, oxygen, phosphorus. So, all these things are required for synthesis of cells as well, hydrogen. So, they synthesize cells out of this new cells, and some of the sort of mineralized or decomposed degraded compounds are either left in the water, or the complete mineralization can make it escape in the form of gas. So, wastewater receiving rivers and streams have some background dissolved oxygen. Okay. Normally any river will have, if river is flowing, it is open to the atmosphere, and then through atmospheric exchanges the river has significant quantity of oxygen dissolved in it near saturation level. Okay. At time even higher than saturation level, particularly if we see in the daytime when the photosynthesis and all those processes are occurring. So, level of dissolved oxygen could actually be super saturated at those times. Now, what happens that there are dissolved oxygen. So, when bacteria tend to decompose the organic matter, they need oxygen for that. They typically oxidize the organic carbon, oxidize the organic materials, and in the process of oxidation, in the process of oxidizing them, they need dissolved oxygen present in the water. Okay. So, dissolved oxygen which is present in the water or in the background water gets consumed in the process. Okay. What will happen that when bacteria tend to decompose the organic matter, they will sort of, if we see the reaction, it is a fairly simple reaction. So, we have organic matter and we have oxygen, and then there are sort of cells. Okay. So, they gets decomposed here, eventually converts to CO2 plus H2O or other kind of things can be made. So, these bacterial cells need dissolved oxygen, and when this organic matter is broken down, the dissolved oxygen is consumed in the process. Okay. So, dissolved oxygen is consumed is fine, but as we discussed in the previous week that dissolved oxygen keeps on getting replenished also from the natural atmospheric transfers and from photosynthesis. So, the amount of oxygen which is consumed in converting the organic matter by the which is consumed in degrading or decomposing the organic matter can give us an idea of how much organic matter is present in the system or how much organic pollutant are present in the system. If there is no limitation of cell, if there are let us say enough amount of cell or bacteria present in the system, so the amount of oxygen consumed in the system will be depending on how much organic matter is present, because the reaction is like this. Okay. So, this amount of oxygen required by the aerobic microorganisms or amount of oxygen rather consumed by the aerobic microorganisms to decompose the organic matter in a water sample, which typically is polluted because there has to be organic matter present in the water, is referred as biochemical oxygen demand or biological oxygen demand. So, BOD is essentially an indirect estimate of organic matter, organic pollution in the water. Okay. What we are essentially measuring is the how much oxygen is consumed in decomposing that organic matter, and oxygen consumed is in a way is proportional to the organic matter present in the system. So, that way what essentially we are determining is how much organic pollution is there in the water. Okay. How we are determining that? We are determining that considering that how much oxygen is getting consumed in order to decompose that organic matter. So, BOD is that estimation where we sort of observe or we see how much dissolved oxygen has been consumed over a period of time, of course, because the oxygen consumed in 1 day is going to be obviously less than the oxygen consumed in 2 day or 3 day. So, it is a time dependent process. So, how much oxygen is consumed in a given time by the aerobic microorganism is actually the BOD, right. So, if we see the microbiology of the BOD reaction, we have organic matter, there has to be dissolved oxygen and there will be more bacteria will be synthesized, and CO2, NH3 and these kind of things will be released. It is a time dependent parameter, as oxygen consumed would increase with the progress of time. Okay, as the time changes, oxygen consumed would also be changing. When BOD levels are high, the dissolved oxygen level decreases because the oxygen that is available in the water is being consumed by the bacteria. Oxygen, whatsoever oxygen amount is available, is getting slowly and steadily consumed by the bacteria. Now, if the quantity of organic waste present in the system is significantly large or very high, then the rate at which the oxygen is consumed is very high. Okay. If this organic matter is very high, so the rate at which DO consumes will also be very high, and probably the rate at which DO is replenished may not match that rate, and then that typically results the depletion of the DO very rapidly, and the water could become anoxic or anaerobic, means there will not be any dissolved oxygen present in the water, and when there is no dissolved oxygen present in the water, the aerobic processes will stop. Okay. A new regime or new type of bacteria may take up, the anaerobic processes may take up. The degradation is still possible by anaerobic bacteria, where electron acceptor changes, instead of dissolved oxygen something else become electron acceptor, particularly the ions like sulphate and nitrate and those kind of things start acting as electron acceptors, and the organic matter still get decomposed, but it no more decomposes to this thing, it rather started producing methane and H2S and those kind of things are started coming in the system. So, further, now the oxygen which is consumed in the water could arise from two different sources. So far we have been talking about the organic matter gets decomposed and in the process the oxygen is consumed, but there is a possibility that oxygen demand could arise from the nitrification requirements as well. Nitrification requirement could also lead to the some oxygen demand. The nitrifiers or nitrifying bacteria, which because there is lot of nitrogenous waste that comes in the form of proteins, amino acids, amines and all those things. So, the ammonia present is converted to the nitrates through the process of nitrification by the autotrophic bacteria, and these autotrophic bacteria use oxygen as an energy source. So, there will be oxygen consumed in this process as well. Now, the requirement of dissolved oxygen for this process, for the process of nitrification or for the process of where ammonia is getting converted to nitrate, is called nitrogenous biochemical oxygen demand or NBOD. While so far we have been referring BOD is actually gets a new name as the carbonaceous biochemical oxygen demand or CBOD. So, CBOD is the one which is the oxygen demand which arise for the degradation of carbonaceous organic matter, okay, or organic matter simply, whereas NBOD is the oxygen demand required for the nitrification or required for the conversion of ammonia to the nitrate. So, there are two different type of oxygen demand or biological oxygen demand that are coming out of the system. These both are the biological process. So, both are the biochemical or biological oxygen demands, okay, which are coming, and if we see the total BOD is the summation of CBOD plus NBOD, right. However, normally the rate at which nitrifiers grow is very slow, okay. They have much slower rate and generally they do not flourish till significant amount of time, till around, it has been observed that around 7 the nitrifiers in the system start flourishing only after 7 days, until unless we are amending them. We are talking about mostly the natural system. So, till 7 days there will not be like any demand for the nitrification purpose. So, whatsoever we get till this period is mostly CBOD, and beyond that, beyond this 7-day period, we start seeing the nitrogenous buildup as well, okay. So, if you see, you will see, like if you see the oxygen demand especially for nitrifiers, it will be something like this, you will get some demand like this, and this in addition added to the, because whatsoever the your CBOD or carbonaceous biological oxygen demand, if we add this NBOD to that, what we get is this total curve like this. So, this is our oxygen, this is our total BOD which contains carbonaceous oxygen demand as well as nitrogenous oxygen demand. But generally if we analyze the system before 7 day, we often overlook the nitrogenous the NBOD part, and what we get usually is the CBOD part. And the conventional BOD determination processes, okay, are for determining BOD up till day 5. Okay. So, the conventional BOD measurements that we do is actually only the CBOD part, because NBOD part starts after day 7 and generally we overlook that. For most cases BOD is determined up till 5 day. Why it is determined up till 5 day is because it is a standard test, okay, and it is generally believed that 5 day is long enough period for acclimatization and substantial oxidation. It is not long enough for complete oxidation. So, in 5 day oxidation is not complete, the process of oxidation does not get complete in the 5 days, but significant amount of oxidation or significant amount of oxidation is complete within that 5 days, including the initial microbial acclimatization. There has been some historic perspective as well, the process when it was developed. So, since then only the 5 days is coming, okay, and it is in the trend. One of the theories is that in the Britain no river takes more than 5 days to reach to the ocean. So, whatsoever biological decomposition process has to be has to be there is often there only for 5 days. So, the BOD 5 was used as a standard, and it is basically coming since then only. So, what BOD 5 is, as we were saying, that if we try to see, let us say we are starting a sample, we have a sample and we are starting with a dissolved oxygen level D0, okay. Say initially DO was 8 milligram per liter, okay. Now, if we incubate this sample for 1 day and then next day we try to monitor at day 1 DO1. So, some amount of oxygen would have been consumed in the process, maybe very little, maybe very high. Let us say it has come down to 7 milligram per liter. If we do it on the second day again, we will see further decay, let us say 5.5 milligram per liter. Similarly, DO3 we will see further decay, let us say 4 milligram per liter. Okay. DO4 again we saw that 3.2 milligram per liter, DO5 we saw 2.5 milligram per liter, we did DO6 we again saw let us say 2 milligram per liter, DO7 say 2 milligram per liter or 2 milligram per liter. So, that way this is obvious that as the time progresses the dissolved oxygen level will keep on decreasing, okay. And if you try to plot this, you will see that your initial DO is somewhere here and with time it will keep on decreasing, okay, and then it reaches a saturation value or somewhere there. Now, let us say this is my day 5 and this is for say let us say any day x, okay. Now, for typically reporting purpose the 5 day DO is used, which quantifies the oxygen consumed in a sample within a 5 day period. How much oxygen is consumed in a 5 day period, okay. So, the procedure is simple. So, like we have listed different DO. So, you take DO 5 minus DO 0, what was the initial 0. So, this is the amount of dissolved oxygen that has been consumed in 5 days, you divide it with the sample volume. So, that means you get this much milligram of oxygen has consumed per unit you put it with the dilution factor or whatsoever appropriately. Okay. Eventually you want to convert it to the per liter of sample. So, per liter of sample, how much water, how much dissolved oxygen has been consumed, that will give you the BOD value. Okay. So, BOD 5 is equal to this minus this divided by the dilution factor and volume, similar that way, right. So, that is how we can get the value of BOD. Now, coming to the this point again, in 5-day period we can get certain DO. This will keep on decreasing, but it will not decrease beyond a time. Okay. By this time all the possible oxygen consumption, all the possible reactions which need oxygen has taken place, and since those reactions are complete, either the organic matter is completely sort of degraded, decomposed, or it has decomposed to a level beyond which there is no further decomposition is possible. So, thereafter you keep it for howsoever long, your sample is not going to decrease, dissolved oxygen is not going to decrease further. So, this is called ultimate BOD, okay, or BODU, and this quantifies the oxygen requirement for a total biochemical degradation of organic matter, whatsoever possible degradation. Okay. So, similarly for ultimate BOD you will have to use DO final for whatsoever long it takes, and you need to subtract that DO final from initial DO 0 minus DO final. Okay. So, initial DO minus final DO will give you the how much dissolved oxygen has been consumed, because this has been left over. Similarly, like as we are discussing, initial DO minus DO on day 5. Okay. So, this will give you 5-day, indicate the 5-day BOD, this will indicate the final BOD or ultimate BOD. Okay. And most commonly 5-day period is used. This BOD test is a standardized test where we take this DO and subtract from the initial DO and know the oxygen consumed during this period of incubation, and that is how the BOD tests are done. The next parameter is chemical oxygen demand, which is COD. We just discussed the BOD. Now, with BOD, one criteria is that we are trying to see how much organic matter gets decomposed by the bacteria. Now, the organic matter, there are it is not possible that all the organic matter can be decomposed by the bacteria. Okay. We know that polythenes are also organic, but bacteria cannot decompose polythenes. Okay. So, similarly there are variety of other complex organic matters which are non-biodegradable. So, you can say that waste or organic matter could be biodegradable or could be non-biodegradable. So, the BOD only targets the biodegradable part, because your aerobic bacteria or group of bacteria or biomass can actually decompose only organic matter which is biodegradable. They cannot degrade non-biodegradable compounds, okay, or non-biodegradable elements. So, then how we estimate the non-biodegradables? Well, then other parameter is the chemical oxygen demand, where the organic matter in wastewater is estimated in terms of oxygen required to oxidize the organic matter chemically. So, earlier we are doing it biologically. Now, biologically it may not be possible to degrade all the organic matter, but chemically it is possible to degrade majority or almost all of the organic matter, because we use very strong oxidant, strong chemical oxidant, potassium dichromate in the boiling sulfuric acid. So, we use it at a high temperature in acidic medium with a very strong chemical oxidant, so that almost all the oxidizable compounds are oxidized. Technically, COD and BOD are the two different ways to measure how much oxygen the water will consume when it enters to the recipient water body. Okay. Since the biologically only biodegradable organic matter can be oxidized, and while chemically almost all oxidizable matter could be oxidized, the COD values are always higher than the BOD. Okay. Because as we were discussing, we in BOD we are targeting only this, while in COD we are targeting all the oxidizable matter which is present in the system, which can be oxidized by the dichromate or by the presence of oxygen. Typically, dichromate is used as we are discussing. So, for the measurement purpose, when organic matter is oxidized by dichromate in sulfuric acid, most of carbon is converted to CO2, hydrogen present is converted to H2O. The reaction illustrate the primary standard potassium acid phthalate. Okay. So, this is your KHP, okay, which is typically reacts with the dichromate in the presence of H2SO4, and it actually mineralize this. So, here what happens that the dichromate ions are orange colored solution, while the chromic ions which are there basically turns the solution green. So, when this reaction is completes, the solution turns green, and then by titration or by the spectrophotometric color measurement, as we discussed earlier, we could actually determine. The COD could determine theoretically also, because it is a chemical oxidation procedure. So, for say our standard, which is potassium hydrogen phthalate, the governing reaction is this. Okay. So, this reacts with 7.1 mole of KHP, reacts with 7.5 mole of oxygen. Okay. So, correspondingly we can see how much is the theoretical COD of KHP. Okay. We know that this is 7.5 into 16 into 2. So, this much gram of oxygen is required in let us say if the molecular weight of this is KHP is m KHP. So, m KHP gram of this needs this much of oxygen. So, how much is the oxygen requirement for 1 milligram or 1 gram of KHP can be estimated theoretically. Conceptually, all organic matter which are made of CH and O, okay. So, if it is CX, HY, OZ, they will need this much moles of oxygen, okay, for degradation or decomposition, and then we can get the COD value for these compounds using this. So, it is we can write equation and see based on the molecular weights how much it is coming, and that way we can estimate the theoretical COD of these compounds. So, this way BOD and COD both are very important parameter, very critical parameter. The water bodies that gets polluted because of organic matter and the depletion are also primarily because of the organic matter present, and these are the indicators of the organic pollution, primarily organic pollution in the water. And although the procedure for measurements are different, since COD is more closer towards the measurement of total organic carbon. So, COD can nicely be correlated with the total organic carbon as well. So, with this we conclude this session, and we will continue the discussion of the remaining water quality parameters in the next lecture. Thank you.